This is the Happy Scientist Podcast. Each episode is designed to make you more focused, more productive, and more satisfied in the lab. You can find us online at bitesizebio.com/happyscientist. Your hosts are Kenneth Vogt, founder of the executive coaching firm Vera Claritas, and Dr. Nick Oswald, PhD, bioscientist, and founder of Bitesize Bio.
Hello, everyone. This is the Happy Scientist Podcast. Each episode is designed to make you more focused, more productive, more satisfied in the lab. You can find us online at bitesizebio.com/happyscientist. Your hosts today are, of course, me, Kenneth Vogt, founder of the executive coaching firm Vera Claritas. Today, I have with me a special guest to co-host, and that's Zara Puckrin of Bitesize Bio. Now, I work with Zara quite regularly, but I realized I have never referred to her by last name. I literally had to go look it up. Zara's been at the bench just like you. She's in a different role now, but maybe, Zara, you can tell our listeners what you've been up to. What's your potted bio for today?
Yeah, so I used to work in the lab doing molecular biology, cancer-based research, and now I work in marketing. I'm really excited to be here. When I first joined Bitesize Bio, I binged The Happy Scientist, so it's really special to be a co-host today, and really excited to hear what you've got to say, Ken.
Cool. Well, and I'm excited to hear what you have to add into it all. Here at the Happy Scientist, we have a topic every month, and this month our topic is going to be fix it or start over. So the idea is, how do you make the right decisions when it comes to when there are problems in the lab, when there are things that are not going smoothly. And there's lots of different possibilities here. And there can be hidden costs to just being indecisive or of misjudging your fixes. You do things to try and fix a problem, but maybe they don't quite solve the problem, or maybe they solve the problem, but they create other problems. So how do you know when you need to tweak the protocol, or when you just need to overhaul things and really start approaching it differently? This is a critical career skill. It's something that everybody needs to get good at. And sometimes I think we rely on say our boss, or we rely on the established written protocol, that's the Bible. We have to do it that way, and we don't bring our own understanding or our own viewpoint into it. But if you're going to grow, if you're going to be valuable in the lab, then you're going to have to get good at this. And I say it that way, not like, oh, you're doomed if you don't get good at it. You will get good at it. It's an acquirable skill. This isn't just some amazing talent that only special people have. You have it too. You can bring you to the lab, and it helps to recognize that you are brought in because of that possibility. You're not just a cog in the wheel. You're not just a trained monkey, and I mean, we're talking to PhD scientists here, and even if you're not at the PhD level, you're still at a highly trained level, a highly educated level, a highly skilled level. So you need to bring all of that to the table. It matters. Okay, so I want to start off with looking at, how do I address things like this? Something is not right. Something is not smooth. Something is broken. What do I do? And something that happens to us often is we get excited to get to the finish line. So we start trying to fix problems before we even really got clear on what the actual problem is. So start thinking about it this way. Whenever there's a problem that pops up, you want to triage it. And I always think of the the television show MASH when I think about triage, because there was a really good pictorial representation of triage. Triage is a chaotic time where time is of the essence. We have to make decisions quickly. We got to move quickly. We got to deal with what's happening on the ground right now. That is a good representation of this. It isn't like, okay, let's stop everything and put everything on hold until we figure this out. Because that is often not a possibility. I mean, it's especially true for biologists. I mean, you're literally dealing with living things. You may not be able to wait around and take a week to think about it, a day to think about it, an hour to think about it. You got to deal with what's happening right now. So, we start off thinking in terms of triage. So we're triaging the problem, not the solution. We'll talk about the solution later, but right now, all we want to know is what is the problem. So is this a situation where something is consistently failing, or is it that occasionally things get off track? There's a big difference in how you'll handle that problem depending on whether it happens every time or it happens only some of the time, or even infrequently. Just because something happens infrequently doesn't mean it's not a problem either. But it's good to know that. You need to know what the problem actually looks like. Another thing to think about are the symptoms of this problem. Are they isolated or are they systemic? That is, does this always happen? Does it happen every time at this point in the protocol, for instance? Or is it just like a contamination, say well, it's contaminated. What happened? How did that even take place? It's not normal. It's not regular. But maybe while it doesn't happen every time, it happens frequently enough that you care, that you want to do something to head it off in advance in other situations. Another way of looking at a problem, is it a strategic problem that is a big picture problem, or is it an operational problem that is something that happens day to day? Does this just, I regularly in various settings encounter this problem because it's a problem in the lab. It's a problem. Maybe it's a problem every time I work with this person, right? Or it could be just like, it doesn't matter who I'm working with. Every time we get to this step, it breaks. So what you have to know at this point is what is actually working right now and what is it that's not working. So let me take a breath here and allow Zara to weigh in. Is there any thoughts on scoping out the problem here, Zara?
Yeah, I think sometimes, at least when I was in the lab, and even today when I'm not in the lab, when I'm doing my day-to-day job now, I can really overcomplicate a problem, and sometimes the solution's really simple, but I'm maybe thinking too much about it. And maybe just having like another perspective, even if it's someone who's not in the lab, even if it's your mom or a friend who doesn't work in the lab, sometimes the problem is actually really obvious to them because we're thinking of it from a scientific point of view, and actually it's not a scientific solution, or it's something else. So it reminded me of that. So often as well, it's equipment that's actually the issue rather than your protocol. Maybe it's a piece of equipment that's broken. Happens so often too.
Yeah, that all makes sense, definitely. And I chose this particular illustration about scoping out the problem because look at that. It's a bunch of spaghetti. It's all a mess. Maybe not. Maybe it's just one spot, just one little place, and it's really good to get clear about that. And I like what you mentioned, of bringing in eyes that might not be fellow scientists. You literally mentioned talking to your mom, which you think, well, my mom's not a biologist. I don't know how she could help. She could help because she's got a fresh view. She doesn't have the bias that comes with being part of the machine, right? Part of the structure. Now, I'm not saying that everybody's mom is the solution for all of that, but you may have friends outside of your industry or just outside of your lab. And it's not that they're tainted because they have biological training, but it also means that don't get fixated that every problem is a biology problem. Every problem isn't. You mentioned it could be an equipment problem. It could be a protocol problem. It could be a managerial problem. It could be a training problem. It could be a staffing problem. There's all kinds of problems that can impact you that are outside of your specialized purview. And it's good to recognize that. And it's also, this is a point of being realistic. Everything that you encounter will not be solved in a petri dish, or that's not how this works. And I think sometimes we have naive notions when we start that I just want it to be purely about this. I've mentioned before my background. I am not a biologist. I'm a computer programmer. Boy, I liked everything to be solved with code. And it's really easy to look at things that way, that everything should be computerized. And no, everything should not be computerized. Some things should be done manually. Some things should be done mentally. We got to put in the right effort in the right places at the right time. And we have to recognize that where the problem stands there. Because, it's certainly possible that you're working with somebody that's just not smart enough. And that's the problem. And, you can have situations, and it's not a matter of saying, oh, this person's stupid. It's like, maybe they're not trained in quite the right area. There's a difference between a biologist and a chemist and a physicist, that they have different areas of expertise. Of course, they look at the world differently as a result. And sometimes the right view is a different view than the one they have. And we need to recognize that we too fit into that. If we think, how does the saying go? That if you can't put a square peg into a round hole, right? And if you think every problem has to be solved with this square peg, that's just not accurate. So just to get you thinking, sometimes you got to step a little outside of the box of what actually is the problem. Okay, so you've established the problem. You've figured it out. You've not got ahead of yourselves. Like, I got myself clear. I understand the problem. I get it. I know what's there. Well, then, of course, the next thing is choosing how are you going to solve it. And this is a step that often gets skipped again. Again, we want to go straight to solve the problem. But first, you have to decide your action framework. And there are different ways to do different things. Is there something wrong here that just needs to be repaired? Is it so bad that repair is not really practical, that we actually need to renovate? We need to kind of step back and do a little better job. We keep the basic framework, but we have to make bigger changes. Or maybe it's just totally a wreck. It needs to be remodeled. We need to scrap this and rebuild it. And it's hard when you get to a setting like that. You think, you know what? I don't want to consider throwing away everything. A lot of work went into the protocol that was established here. We've got a lot of precedent, and we've got people that are committed to the way it is. And it's hard to make that choice, to say it's time to remodel. But if it's required, you got to have the nerve to be able to stand up and say, yeah, this is it. We've tried renovating, we've tried fixing, we got to remodel. There's one other possibility, and this is one that a lot of people just never look at. That is, you could just accept this is the way it is. I've been calling this a problem, but apparently we've survived this problem before. We have workarounds, and we're still getting the objective met. Well, then it's time to just accept it. Just suck it up. Yeah, it's not fun. I don't like it. But that is one of the options you have. Now, if you went straight from problem, you skipped over the problem, went straight to solution, accept is almost never on that list. To just take it, right? We don't like that. And I'm not recommending this as like this is the best one. I'm saying that when it is appropriate, it's appropriate. So at any given point, you got to decide what is the appropriate solution now. Is it to repair? Is it to renovate? Is it to remodel? Or is it just plain to accept? So again, Zara, let me ask you if you could step in here and tell us what your experience has been.
Yeah, I think with science, sometimes there's some problems that are too big, like beyond our control as an individual scientist. For example, I know a lot of scientists talk about the problems with funding. It's a big issue about funding and the impact and the kind of bureaucracy and the politics of it is maybe something that's quite out of our control. And one of the things that I find quite helpful and I like to do when I have if I have a list of problems, or a lot of problems, or I feel overwhelmed, I write down things that are in my control, things that are that I can kind of control, like the results of an experiment, for example, but it's not 100% on me. And then things that are out with my control and I need to accept. Sometimes that's a nice way if you've got multiple things going on in an experiment, or even in your life and in science, just think about science generally. That's quite a nice exercise to do because it kind of shows you where you can repair and renovate and where it's better just to accept that is out with your control, but you can do, but think of the things that you can do is helpful.
Yeah, definitely. And of course, at different times in your career, you have different possibilities available to you. If you're early in your career, maybe all that's available to you is to fix your own problems, and your very localized problems. You may not have any say over whether or not things are renovated or remodeled. And it may not just be that you have no say. You don't even have a voice there. No one's asking your opinion about scrapping the protocol, right? And that's fine. Accept what is, if that's the environment you're in. Now, if you're more senior in your role or farther along in your career, you may have other options, and you should take them, even though you couldn't take them in the past. But now that you're in a more senior role, you need to accept that responsibility and step into it, because you're the one that needs to do it. Because the people that are junior to you, they're not allowed to do it. So it has to be you. And it's important that you continue to grow in your own, not just in your role in your lab, but your role in the industry, in science. And part of that is going to come sometimes not because I can't solve this problem, but what I can do is I can champion a solution to this problem. I can bring it up. I can write about it. I can speak about it. And that speaking might just be talking to people in your lab, or it could be on stage. And you don't always have to have the solution to the problem. Your role might be at this moment just to be the person speaking up about the problem. You may not even know a viable solution. But if you can get the problem out there and get people engaged with it, solutions may start to come from that. And you don't have to be the only one. The buck doesn't always stop with you. You don't have to be the only one to identify the problem, the only one to establish a solution, the only one to implement the solution. That's not how it works. Science is far more collaborative than that. You want to be part of the solution, not solely the solution. So now I want to talk about ineffective changes. Sometimes we confuse activity with impact. It's like, I want to solve the problem, and that should count for something. Well, not if it doesn't actually solve the problem. I remember a situation that happened when my children were young, not babies, able to actually participate in the household. So one of the things that my kids were tasked with doing was to clean up the dinner table after dinner. So I remember one day it's my daughter's turn to do it, and I come in and like, the table's still sticky. What's going on here? And I told, I said to her, how come you didn't clean the table? She said, well, I I I did clean the table. And I said, wait a minute, I see the problem here. I even put it to her that way. Why didn't you clean the table? No, the objective was to get the table clean. It wasn't to go through the motions of cleaning a table. And without that objective being clear, we didn't get the result. And I'm not blaming an 8-year-old for this problem. It was my lack of guidance. So you gotta recognize that you need to be part of the solution here. You need to be thinking about, am I actually getting the result that I'm seeking as a solution here? So we've all done things where like, well, something was a problem, so we tweak the protocol a little, and then months go by, and then we realize that didn't actually solve things. And so we have to own that. We got to recognize it. We got to be able to say that this didn't work, so we can do something else. Now, sometimes you might do something it's a bold change, and that unlocks all kinds of possibilities and growth. Now, of course, bold changes can be very painful, and they can cause problems for other people. So, we have to see what's actually working, and we have to be nakedly aware about it. We can't delude ourselves that just because I took action, that's all it's needed. We have to drive to what is the final result that we're after. And I'm saying this to scientists, and I almost feel like I shouldn't have to, because this is literally what you do all day. It's a regular part of things, and you're dealing with living things in many cases. At that, if I make a mistake, if I do something wrong, if my activity isn't perfect, things die. Now, I'm not saying that we should get all misty-eyed about single-celled organisms that die, but sometimes you're working with higher level critters and you don't want them to die, and that's fine. But the point is that what we're doing has an impact, and it has an impact in the very short term. It might impact this literal experiment, but it could impact the overall objective here. What are we trying to do? Are we involved in some kind of drug discovery? Are we trying to solve a very human problem that is going to matter? It's going to affect people. We have to take responsibility at every step and at every level. So if we're not effective in the changes we make, the changes don't count. We don't get credit for making changes. We get credit for getting results. So again, I will pause and see what Zara's got to say here.
Yeah, I think sometimes you can have not have a clear path, so you might have a number of options too that you want to try. And I think sometimes if you have options like that, you can feel paralyzed and maybe not want to take action in fear of getting something wrong. But if you have lots of options, it's a good place to be. And if you don't know which one's going to work, it's better just choosing one and doing it than procrastinating on it and being worried about getting it wrong. Yeah,
that's a very good point. It's not like we have to be perfect at every step. We're setting a bar that's impossible if we do that. Some changes will have negative impacts. Some changes will have positive impacts and negative impacts at the same time. It's fine. Let's see that. I mean, it's just like it's experimenting, folks. This is as fundamental as it gets, right? And we want to be engaged in experiments. We're gathering data, and then we're going to assess the results. And not every result has to come out perfect. And I realize you're in an environment where often you're being told to get a certain result. You're being pressured to get a certain outcome. Well, it's not always possible, and it isn't fair that that's being asked of you. So, but that is part of the environment in the lab these days, especially these days. So you need to know that. But a lot of times you're solving problems just for yourself, and the only judge of what happens now is you. Well, be a good, impartial, non-judgmental judge. That is, make assessments, not condemnations. You're not bad because a certain change didn't get the result you wanted. You just as you weren't bad when you called out a problem. That's fine. It's perfectly fine. You're allowed to do that. Now, let's just make sure that our changes, our problems aren't fatal, right? And I don't necessarily mean that as literally fatal, but fatal to the outcome that we're seeking. We want to be able to recover from things. So if you follow this protocol of first establish what the problem is, get clear on the problem, and only after that you start examining solutions. And you got to stop yourself sometimes. Sometimes you got to call out other people saying, well, we're not at the solution stage yet. We're just identifying the problem. And then once you get to the solution stage, like, okay, what is the appropriate framework for approaching the solution? Is it repair? Is it renovate? Is it remodel? Or is it accept? Should we just leave it alone? It's just something we're going to have to deal with. If this is the way that you approach things, then you're going to make far better decisions. You're going to draw far better conclusions. And does it work every single time? Well, I will ask you of your experience. Does everything work every time in the lab? I imagine the answer is no. And you have to accept that. That's part of the environment. Just make sure that everything is survivable. So, Zara, I'll ask, do you have any closing thoughts on fix it or start over?
The last little closing thought I had was about decision fatigue. And if you're someone who's quite senior and you have to make a lot of decisions, maybe something to think about. I know Steve Jobs was very much a fan of this and used to wear the same outfit every day to kind of prevent decision fatigue. So that's one of the things the last thing I could think of that might be helpful.
Yeah. That's almost a whole nother topic. The topic of decision fatigue. We may have to get into that sometime. It's easy to say, don't get all stressed out. It's like, well, there's an expression there. When you're up to your neck in alligators, it's hard to remember your objective was to drain the swamp. So, yes, sometimes we do feel like I am just surrounded by alligators. But we deal with those alligators one at a time. Knock that one off, move to the next one, do the little ones first, get the big ones next. There's lots of possibilities for approaches there. But the fact is, you were engaged to solve problems. You are supposed to do that. That's why they hired you in this lab. And that's why you bothered to get all that education, so that you could be better equipped to solve problems. It's just good to recognize that not everything has to be fixed. Not everything needs to be burned to the ground and started from square one. There are lots of approaches you can take, and it's up to you to pick what's appropriate for the problem that you're facing at this time. So that will cover the topic for today. The Happy Scientist is brought to you by Bitesize Bio, your mentor in the lab. Bitesize Bio features thousands of articles and webinars contributed by hundreds of PhD scientists and scientific companies who freely offer their hard-won wisdom and solutions to the Bitesize Bio community. So thanks for being with us today. and we look forward to having you with us next time.
The Happy Scientist is brought to you by Bitesize Bio, your mentor in the lab. Bitesize Bio features thousands of articles and webinars contributed by hundreds of PhD scientists and scientific companies who freely offer their hard-won wisdom and solutions to the Bitesize Bio community.